Welcome back to section 4.2. What I'd like to do in this video is go through several examples of dealing with exponents, and hopefully those will touch on some of the questions you may still have about working with these kinds of problems. Now let's review the two rules that we talked about in the last video. Rule number 6 basically stated that if I have x raised to the negative m, then that's the same as 1 over x to the m. Rule number 7 is a variation of that. That simply says if I have a fraction raised to the negative exponent, then I can take the reciprocal of that fraction and change the negative exponent to a positive exponent. Now there's another way to think about this rule number 7 that I would like to talk about for just a moment. Now think about the fact that you have a to the b raised to the negative m. Now if I go back and apply the expanded power rule here, one way I could choose to write this is I could choose to write this as a raised to the negative m over b raised to the negative m, because again this negative m affects both the a and the b. Well, if you look at what we have up in the rule itself, I could apply the expanded power rule here as well and say that this is b to the m over a to the m. Again, that would be simplifying that down a little bit further. Now take a look at these two expressions. Notice that they are upside down from each other. So in order to get this to look like what I have up here in the rule, I would need to take the a to the negative m and move it to the bottom, which would give me a to the positive m, and the b to the negative m I would need to switch over to the top, and that would give me b to the positive m. So now notice that these two expressions actually match. So another way to think about negative exponents, if you have a bunch of them within a particular problem, one way to deal with it is to keep this statement in mind. If an exponent is negative, you can cross the fraction bar and make it positive. So, in other words, let's say, for example, that I gave you the problem 1 over 3 to the negative third. Now we haven't looked at that where we have a value in the denominator that's negative. Now according to the statement I just wrote, what that says is I simply take this 3 to the negative 3, bring it up here, and make it 3 to the positive 3. Now that would leave a 1 in the bottom because I moved that up. And so this would then become 27. So it's a little shortcut that you can use to be able to simplify some of the negative exponents. Let's try one other one. Suppose that I had something more complicated like x to the negative third over x squared y to the negative second. Now there's two x's in this problem that we want to simplify, and a y. Now some of you I know are not real fond of working with negative exponents. So this particular little trick I'm talking about here can help you not have to deal with negative exponents. So to start with, I might actually rewrite this by putting the x on the bottom and bring the y to the top. Now notice this x squared is already positive. It stays down here. It does not move. But my x to the negative third is going to come down here. So if I bring it down, I'm going to get x squared times x cubed. Likewise, my y to the negative 2 moves to the top and becomes y to the positive second. Now this problem isn't quite done yet because I can actually still simplify it further. So on top I will have y squared. On the bottom, x squared times x to the third becomes x to the fifth. And so this little trick of crossing the fraction bar can make the work with simplifying these exponential expressions a whole lot easier. All right, let's look at some more examples here. And I just want to go through a series of 5 or 6 examples, and hopefully those will help a little bit. So let's start with some simple ones. Now suppose I have x to the negative 4th. Now keep in mind x could be written as x over 1 raised to the negative 4th. If I write it that way, I can apply my rule number 7, which says if I have a fraction, take the reciprocal. So I can write it as 1 over x raised to the 4th. And notice that it's outside the parentheses, so this becomes 1 to the 4th over x to the 4th, which is 1 over x to the 4th. Now clearly I took the long way of getting to the end result here. And I did this a little bit on purpose because I want you to be aware that there are multiple ways of getting to the right answer. So let's say that I take a look at this problem again, x to the negative 4th. Now I could have just chosen to apply rule number 6 and just said this is 1 over x to the 4th, and I would be done. Now that's certainly much quicker than what I did up here, but as long as I apply my rules correctly, I will always end up with the same answer. And like me, there's some of you that may not always see the quickest way to get to the end result. Okay? All right, let's take a look at another one. Suppose that I had negative 2 raised, or the opposite of 2 raised to the 4th. Now if I write it this way, it is actually going to be the opposite of 2 raised to the 4th. Now we talked about this one in the last video. You want to think about this as being a negative 1 times 2 to the 4th, which is negative 1 times, now 2 to the 4th. I can multiply that out. That's 16, and that becomes negative 16. If I had, however, wanted to do negative 2 to the 4th, again, I would need to write it with parentheses. That now is going to mean negative 2 times negative 2 times negative 2 times negative 2, which is a positive 16. So again, just a reminder that when you see these written, these do mean two very, very different things, and they're going to give you two very different answers. Okay, let's look at another one here. Suppose I have x to the 4th times x to the negative 7th. Now there's a couple of ways that you can do this problem. Now if I apply my rules straightforward with the same base, I can add exponents. I could do this and have x to the 4 plus negative 7, which gives me x to the negative 3rd. Now I can apply my negative exponent rule, and I could write it as 1 over x cubed. Okay. Now another way I could do it is I could choose to rewrite this. If I have x to the 4th times x to the negative 7th, I might think of writing this as x to the 4th times 1 over x to the 7th. So in essence, what's happening here is I'm going to end up with x to the 4th over x to the 7th, which if I apply my quotient rule is still going to give me x to the 4 minus 7, which is going to give me x to the negative third. And notice that will still give me 1 over x cubed. It will give me the same result. Now the first way might be a little bit quicker in this particular case. But again, depending on how you choose to approach the problem, you will end up with the same result looking at it both ways. I'm going to end this video at this point in time, and in the next video I'm going to look at some more difficult problems that are going to require quite a bit more simplification.